And we're going to start with this. This is just about the back side. And we're going to graph polynomials. We're going to start with first degree. So like y is equal to x. And you guys all know that that looks like this. Right? And what does x squared look like? Yep, it looks like a parabola. How about that third degree? And that's accurate if it's just x to the third. But the question is, what if it's like y equals x cubed and then minus 3x squared and then plus x and then minus 3? And the truth is that you can start to get that kind of a shape, where it has kind of ups and downs. And then the fourth degree looks something like that, kind of like a W type shape. Now, this is what I want you to do all throughout math class. This is what makes math class exciting. But I'm going to help you do it. Let's look at this. See how this has just one bump in the graph? And a third degree has how many bumps? 2. And a fourth degree has 3. So a fifth degree is going to have 4 bumps. So it's going to look like this. 1, 2, 3, 4. Okay? And so that's the first important part, is that given a polynomial of degree n, there are at most n minus 1 extrema. And when we say extrema, what we mean is maximum or local maximums or local minimums, those bumps that happen within the graph, where it changes direction from going up to going down, so on and so forth. Now, all of these graphs are positive, meaning this would be a positive x to the fifth, a positive x to the fourth. Watch when we draw the negative ones. And what's going to happen for the negative x squared? It's going to flip. And then the third degree is going to do something like that. And your graphs do not have to be perfect, folks. Your fourth degree is going to look something like that. And your fifth degree is going to look something like that. And all of a sudden you're like, wow, we're getting some really cool shapes. Like, are we actually going to be able to graph that stuff? How do we know where they go? And that's what we're going to teach you. But these general shapes is what you want to keep in mind. And you are ready to learn the most important part of being successful today. And as you know, I always am transparent about the type of things you're supposed to know for the test. And so we begin our first part. Here's what you're going to have to know. Please focus on all the red graphs. See the red graphs? They are all positive, okay? Don't look at the direction where they start. Look at the direction in which they finish. All the red graphs finish going up. First thing you need to know for the day. Everybody see that? If they're positive, they finish up. Now, please look at the blue graphs. As you see the blue graphs, they all finish going because they are all negative. If it's positive, it finishes. If it's negative, it finishes down. Excellent. Now that we figured out how it finishes, now we're going to figure out how it starts. I want you to look and try to figure out, see if you can determine how it starts. Parents, share, and talk. You should notice something. Go, talk. How does it start? Go, talk.
A lot of energy today.
I love this unit. It's a fun unit. Yeah, it just happens to be how it's organized. I don't know. 5, 4, 3, 2, 1. Who's got something for me? Say something intelligent. Yo.
If it's to an even, then it starts up, and if it's too odd, then it starts down.
Interesting. If it's, so I'm going to help her contextualize exactly what she said. She noticed that the even ones are starting up, whereas the odd ones are starting down. How about this? The even ones start and finish the same, don't they? The even ones start and finish the same. The odd ones start and finish opposite. You see that? Odd ones start, and here's why, folks. It's very simple. If we were to take a large number and square it, is that going to be positive or negative? Positive. If we were to take a large negative number over on this side and square it, you would get positive. See how either way these produce positive? So they produce the same. Whereas in this situation, say a third degree, if you take a large number and cube it, you're going to get positive. Whereas you take a large negative number and cube it, it's going to be opposite. See that? And that's why they go in opposite directions, because the positives and negatives are treated differently. Whereas if it's an even function, it doesn't matter if it's positive or negative, does it? Okay, they turn out the same. Good. Here's the second thing we want to learn today. We're not going to fill out this piece. I've learned it's really not important. But we need to learn about single roots, double roots, and triple roots. And single roots look like this. A root is where it crosses the x-axis. We call it a root. It's also called a zero. It's also called a solution. Zeros, roots, and solutions are synonymous when we're talking about algebra and graphs. Okay? So that's a root. That's a single root, meaning it passes through, no problems asked. But if we get to double root, it looks like this. It just touches and it bounces off. What shape does it kind of make? A parabola. And if it's a triple root, it makes this shape, which looks like what? A cubic, right? Exactly. So we have single roots, double roots, and triple roots. And what's great about this unit is we get to see the end right away. So take out your calculator so you can see how beautiful this is. Exactly. Can't use it on the test, but we are still going to examine in class. Okay, here we go. I want you to tell me this solution at -2. Is it a single, double, or triple root? It is a triple root. How about here at 1? Is that a single, double, or triple? Double. How about at 4? It's a single. And how about at 7? It is a triple. So watch how I can come up with this. Doesn't that look like a complicated graph? Like you're thinking to yourself, oh my gosh, Mr. Gens, the equation for that graph must look ridiculous. We're going to come up with it in about 10 seconds. If it goes through -2, then I know that I know it must be of this form, x plus 2, and because it goes through -2 and it's a triple root, it's going to be x plus 2 cubed. A triple root.
X plus 2?
Yep, because it goes through -2. See that? See the difference? So what would you plug in to make 0? You would plug in -2. All right, where's the next spot it touches the x-axis?
1.
So it's going to be x minus 1. And it's a double root, so it's going to be squared. And then it goes through 4, so it's going to be x minus 4. And then we're going to have x minus 7 to the third. Now, if you look at that, we have third degree, second degree, first degree, third degree. That makes a total of 9th degree polynomial. This is an x to the 9th right here. And if you, let's, actually, instead of you typing it, how about I just type it in? So I typed into my calculator. If we do everything right, now just notice that this graph is a little bit out of whack. So I have to go into my window here, and I have to put a -4 and an 8. A tick mark every 2. I go down to 50,000 up to 40,000. A tick mark every 10,000. If we've done it correctly, the graph should look the same, right?
Yeah.
Let's see what we get. Look at how we were able to look at that function and determine the equation just like that. Yeah. Ridiculous the accuracy of which we have. So flip to the front of your notes. Let's learn how to graph these beasts. Let's learn how to graph them quickly. Yep. So the first thing that I like to do is I like to determine the degree of the polynomial. These are already in factored form. If we were to multiply this out, would you come up with an x to the first, x to the second, third, fourth, fifth? What would you come up with? X to the second. And as you multiply those out, would it be positive x squared or negative x squared? It's a positive x squared, okay? So this is the organizer I kind of use with people as they try to kind of show their work and try to help you understand. So we're going to go back to what we talked about. If it's a positive, then it's going to finish going up. And if it's an even degree, then it's going to start and finish the same direction, right? So it starts up, finishes up. What are the two spots on the x-axis?
Try again.
Oh my god.
Yeah, let's go. Okay, so where does it cross the x-axis?
Negative or positive 2.
Good, so I go 1, 2, 3, and I go 1, 2. It starts up and it finishes up. So it starts up and it finishes up. And we know it's just that parabola type shape. Easy problem. There we got it? The next one, x to what power? X to the third, positive or negative? Negative. So it's going to finish going down. We always think about how it finishes. Since it's negative, it finishes down. Since it's odd, it's going to start and end in opposite directions. So it's going to begin up. Okay, so that's kind of what I help people kind of try to think about. So we got 1, 2, 3, 4, 5, and 1, 2, 3, 4. And it starts up and it finishes down. So this is kind of the puzzle that you then figure out about how it goes. Try number 3 on your own. Go.
Does that first one? Is it x to the second? Is it 0 because
Okay, here's what I'm looking for with your graph. Hannah said that her graph looks atrocious. Now, I would give full credit for Hannah's graph right here. She's going to get better as time goes on. But what I would do want to see is that it passes through those values and that it definitely goes through 0 and 1. So these are just single roots, okay? Got to show it goes below the x-axis here. Let's look at this next one. X to what degree? X to the third degree, because you would square it and then multiply by x. So it would give us an x cubed, positive or negative? Negative x cubed. Okay, so it's going to finish going down. Excellent. Way to go, Mikey. And it's going to start opposite direction. Okay, starts up, finishes down. So I'm going to draw this out. Yeah, it's squared. So that means I have a solution of -4 and -4. That's a double root. What's the other solution? 0. That x out in front makes 0 for us, okay? What's O? Okay. The negative sign makes it go down. Because it's cubed, it's odd. It starts and ends in opposite directions. This one? So if you multiply this out, x times x times x will give a positive x cubed. You don't look at the -1 and the 5.
So how does there a down?
So because it's cubed, it starts and ends in opposite directions. Don't worry about it starting, worry how it ends. Because it's positive, it ends up. Because it's negative, it ends down. It will start opposite because it's odd.
Oh.
Better?
Yeah.
Good question.
When you graph this 4,
Yeah.
Because it's squared, do the second one where it like barely differs.
Yes, exactly.
Go back up and down zero.
Yes. Okay, so Sophie has the right idea here. She knows it goes through -4 and it goes through 0, but it's a double root. That means that it has to just touch at -4. We know that it starts up and we know that it finishes down. Okay? That's what we know. So I'm going to draw it where I just touch and it bounces off and then travels back down. Not really a fan of how I drew that. I'm going to try again. It's a little bit better. That's what I want to see. I do not want to see you pass through the x-axis there. It has to be a double root. Flip it over. How about this? X to what power? X to the fourth will be a positive x to the fourth or a negative x to the fourth. Why are people saying negative? Because they have 3 minus x. It will produce a negative x to the fourth. You are right. So if it's a negative x to the fourth, will it finish going up or finish going down? It's going to finish down. It's going to start down as well because it's even. It will start and end in the same direction. I will mark 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Crosses through -5, -3. Crosses through 3 and 5. You try to draw it on your own before I do. That's what you should get. Next one, x to what degree? X to the fifth, positive or negative? So it's going to finish up. It's going to start down. Goes through what values? Good. So that's what we want to see, is that it's got a triple root at 0 and then a double root at 4.
Oh, it's gonna like slide through here.
See if you can make a prediction about the shape. You know that it starts down and finishes up. It has a triple root and a double root. See if you can draw it. See if you can draw it.
Ugly, but I think I did it right. You give us points for, or you take us points for
I have to tell that it's a triple root and a double root. If I can tell, yes, I would give you 100% for that. That's what I'm looking for. See how it flattens out horizontally? Sometimes people draw it so it flattens out vertically. That would be wrong. Flatten out horizontally. Good job. We're going to move through problem number 10. So we have 4 more. X to what power? X to the fourth. Positive or negative? Negative. So it finishes down, starts down. See if you can draw it. Check it out. Is that what you got? What did you do?
It's like
Got it.
close. No, I cannot get it.
Yep, so you went through -2. You want to pass through +2. You see that? So 2, -1, and 5 are the spots that passes through. That's what a couple people did incorrectly. All good with that? Okay, this last one, we actually won't do 9 and 10. We'll go over the test now. But so what's the degree here? 5. Positive or negative? Negative. So it's going to finish going. So it's going to start opposite because it's odd. Very good. What are the 3 values it goes through? Good. 0, 0, 0, and then -2 and +4. See if you can draw it. Something like that. Is that okay?
Yeah.
That's the idea. Please turn to your homework. And I want you to know that for your homework, the front 8 problems are already factored for you. The problems on the back, those 6, are not factored yet. So you would need to factor them. So factoring is a review in which we will use in this unit, but I'm trusting that you remember how to factor, right?
Totally.
Very good. So that will end our lesson. I will now hand back your tests and go over those.